welcome back to Module 5, Lesson 6, Use the Distributive Property. We're going to pick up where we left off, where our next learn activity is to learn the greatest common factor and distributive property together. And the textbook tells us you can use the greatest common factor, also known as the GCF, to rewrite the sum of two whole numbers with a common factor as a base. The distributive property allows you to write the sum as the product of the greatest common factor and the sum of the remaining factors. Now this is a pretty big concept, and it's something you're going to be using a lot, particularly when you get to algebra, so I'm hoping they're going to take some baby steps with you on it. We're going to go ahead and highlight all of that because that is kind of important. I'm just going to highlight it in yellow. But then we have when numerical expressions are written as a product of their factors, the process is called factoring the expression. That's getting a nice solid green because that is going to be part of our vocabulary quiz. To factor expressions, follow these steps. Find the greatest common factor of the terms. Rewrite the terms as a product of the factors, and then rewrite the expression as a product of the two terms. Now that's real wordy and it's kind of hard to tell what they're saying there, but fear not. We're going to be looking at this with numbers and I hope with some variables as well, but maybe not. Hopefully this video by our textbooks can be as good as the last one because I was pretty impressed with it. Well, the spinning wheel of death.
To factor an expression such as 8 plus 56, start by finding the greatest common factor, or GCF, of the terms. Begin by writing the prime factorization of each number. Then identify the common factors. The GCF is 2 times 2 times 2, or 8. Next, write each term as a product of factors. 8 can be written as 8 times 1, and 56 can be written as 8 times 7. Finally, rewrite the expression as a product of two terms. Since 8 is a factor of each term, the expression can be written as 8 times the quantity 1 plus 7. You can also use the GCF to factor expressions containing variables, such as 45x plus 6. To factor the expression 45x plus 6, begin by writing the prime factorization of each term. Then identify the common factor. The GCF is 3. Next, write each term as a product of factors. 45x can be written as 3 times 15x, and 6 can be written as 3 times 2. Finally, rewrite the expression as a product of two terms. Since 3 is a factor of each term, the expression can be written as 3 times the quantity 15x plus 2.
They really did a pretty good job with that one, but we're going to spend some time working on it. We're going to slow it down because I know the first time you see that, it can be a little bit overwhelming. So let's take a look at example 3, where we are going to dig into this concept a little bit further. They want us to use the greatest common factor to factor the sum of 45 and 72. And I know you're kind of wondering why on earth would I ever want to do this, and at your level, I mean, why would you want to take and rip apart 45 and 72 when there's a plus sign between them? I get it. But you're preparing yourself for bigger things to come, and you're going to be doing a lot of this in algebra, so you might as well learn it now while we're using some simpler numbers to use it with. First thing we're going to have to do, of course, is figure out what the greatest common factor of both 45 and 72 is. Now the textbook has said in their video that the best way to do that is to do a prime factorization of each number. So they've written the expression, and next thing they did, well, they didn't prime factor it at all, so let me go back and prime factor it. We'll take our sheet of scratch paper here. We're going to prime factor 45 using the upside down division I've talked about before. 3 goes into 45 15 times. 3 goes into 15 5 times, so that is 3 times 3 times 5. And let's see, the other number we have is 72. So 72, I'm going to say, well, let's see on that one. 3 is going to go into 72 24 times. 3 is going to go into 24 8 times. 2 is going to go into 8 4 times, and 2 is going to go into 4 2 times, making that 3 times 3 times 2 times 2 times 2. So what do they share? They share, oops, I wanted a different color there. Let's try that again. They share these two 3's. And when you bring those two 3's down, 3 times 3 is equal to 9. And that 9 is where they got these 9's you see right here. Where did that 5 come from? That 5 came from right here, the only thing that was left. You had 3 times 3, also known as 9 times 5. So 9 times 5 is your 45. And the 8, that came from these 2's right here. 2 times 2 is 4, times 2 is 8. So now you have 9 times 8 right here. So you have factored it out as 9 times 5 plus 9 times 8. Now the last thing we're going to do is take these two 9's, we're going to pull them to the front, and we're going to leave the 5 and the 8 inside parentheses with a plus sign between them. That's all there is to doing it. You can go ahead and write a 9 in there if it makes your little heart go pitter-patter. You get that happy ding-ding sound. It didn't ding-ding for me, so sad. But either way, this is what your final answer is going to be. Yeah, I know that's not what your brain says the answer should be, but the problem's not asking you to solve it. The problem is asking you to factor it using the distributive property. Here's a good one for you. Are the expressions 9 times the sum of 5 and 8 the same as the sum of 5 and 8 times 9? Well, yes they are, because the sum of 5 and 8 is 13 either way you go, and 9 times 13 and 13 times 9 is going to be the same answer. That said, this is not what we like to see. We never write it that way with a 9 on the end. Every time now and again some goober math book will do it like that, but it's really not the proper way to write math. And now it's your turn. Go ahead and pause the video, work this problem just like we have shown you. Make sure you're doing the prime factorization to find your greatest common factor, because I'm going to be looking for that in your homework. When I work the problem, I'm going to start off with my prime factorization using upside down division. 14 is easy, that's just 2 times 7. And then we have 28's only a little bit harder. That's going to be 2 times 14, which is again 2 times 7. So we have 2 times 2 times 7. From here we can take and say, what do they share? They share a 2 times 7. And that's going to create a little bit of a conundrum for us when we go to factoring it, but we'll talk about that in just a minute. So 2 times 7 is of course going to be 14 for each of these, so we're going to pull out a 14. Problem is, this 14, if I take 14 out, what do I have? I have 1 left. So that could be rewritten as 14 times 1, and this one, what's left over here, that would be 14 times 2. So I'm going to take and rewrite the problem as 14 times 1 plus 14 times 2. That, of course, will equal to the two 14's coming out to the front times the sum of 1 and 2 in parentheses. And that, boys and girls, is going to be your final answer. Come back over here, 14 parentheses, 1 plus 2, close our parentheses, and check the answer. Like magic. But what if they gave us a problem like this one that involved a variable? Well, the textbook already showed you in the video how to solve it, but we're going to go over it again just to reinforce what they showed us. So we're going to have to take and find the greatest common factor of both parts, and I'm going to go ahead and come over and get some clean real estate here, and I'm going to do that, if I can ever hold on to my pen, as 6x plus 15. Wasn't that the original problem? It was indeed. So I'm going to factor my 6x, which is going to be 2 goes into 6x, 3x times, 3 goes into 3x, x times, so that's going to be 2 times 3 times x, and then the 15, well, that's going to be easy. That's just 3 times 5, 3 times 5. So what do they share? They share a 3. So So this part could be rewritten as 3 times 2 times x is 2x, and this part could be written as 3 times 5. So right here, if I was doing it, I would come down here again and say 3 times 2x plus 3 times 5, which is equal to, take out your 3's, leave your 2x plus 5 in the middle, and you get your answer. Jump back to the way the textbook's showing us, and they're going to make the leap to pulling out the 3 without ever really telling you how they did it. Even though they demonstrated it in their video, this is how you're going to pull out your 3. This is going to be your supporting work. From pulling out the 3, after that, the 3's are going to go to the front, then that's going to leave you with 2x plus 5 in the back. Check your answer. So your final answer of 6x plus 15 in factored form is 3 times the sum of 2x and 5. Once again, it's going to be your turn, your last extra example problem, and then we'll look at the apply and decide if we're going to do it or not. For this one, they want you to use greatest common factor to factor the algebraic expression. That is loading. There it is. 16 plus 4x. Go ahead and pause the video and do that now. So I have my problem, 16 plus 4x, and if you're sharp, you should be able to see what the greatest common factor is in that, but we're going to go ahead and do the upside down division because, if nothing else, it's good practice. 2 goes into 16 8 times, 2 goes into 8 4 times, and 2 goes into 4 2 times. So 16 is 2 times 2 times 2 times 2. Meanwhile, 4x, 2 goes into 4x, 2x times, because 2 times 2 is 4, and then the x hangs in there with it. And then 2 goes into 2x, x times, because 2 times x is 2x. So we get 2 times 2 times x. When we take and pick out what they have in common, it's going to be these two 2's. So those two 2's I would take and bring down. Of course, there'd be a plus sign between them. And then what's left over here, 2 times 2, that's going to be 4. What's left over here, that's going to be x. And I'm going to write all that over here. 2 times 4 plus 2 times x. Now I'm going to factor out the 2's that are in front. And I'm going to leave the 4 plus x inside. And that is going to be the answer that we put in for our answer key. 2 parentheses 4 plus x, close parentheses, and I bet it was because I have a large x there. Let me make that small. We're going to do a small x. My caps lock must be on. Small x, and well darn, 4? It is 4, isn't it? Yep, because 2 times 2 is 4. I screwed that one up. Sometimes I spend too much time talking and not enough time doing math. 2 times 2 is 4, so these numbers should have been 4 here, here, and there. I think this one's pretty doable. Win is buying bottles of apple juice and wants to mentally calculate how much they will cost. He buys 5 bottles of juice at $2.15. Apparently there's no tax there. And he wants to use the mental math and the distributive property to determine how much change he will receive from 20. Well, this is how I think I would go about solving that problem. I would start off with the 5 times the $2.15. But then I'd go and I'd say, I can break that down to stuff I can do in my head. I can use it, say 5 times the sum of $2 and of 15 cents, because I can multiply both parts of that in my head pretty easy. From there, I'm going to use my distributive property. 5 times 2 plus 5 times your 15 cents. 5 times 2, that's easy. That's going to be 10. 5 times 15 is a little bit harder, but it is 75 cents. And from there, you add those two numbers together, and you find out that his cost of his apple juice is going to be $10.75. But that's not what it asks. It asks how much change would he get from $20. So from there, we're going to take our $20, we're going to subtract our $10.75 from it, and when we do that, we're going to find that he has $9.25 credit. Now, I did all this writing it down because I I'm a 6th grader and I know that I have to show supporting work even for my mental math. This is how I would have done that mental math in my head. Jump back over to my problem, which is right here. Scroll down. Where's my solution spot? And the change I have is $9.25. Check it, and it checks. I think that's enough homework or enough examples for y'all today. Get started working on your homework assignments. Make sure you give me good quality supporting work so I can give you good quality credit when I grade it.